All right, this is lesson 3-4, but there's a few homework problems from 3-3 I left unanswered that I said we would discuss in class. So let's discuss these now. Angle ABC, that's this angle here, and angle DBC, that angle there. Those are not vertical angles. They are side by side. They have, each one of these angles uses segment BC as one of their sides. If they have a side in common, they are not vertical angles. Okay, so these are not. ABC and OBV, ABC, it's that one there. And then OBV, that one there. There you go. Those two are vertical angles, right? 4 distinct segments used in the making of those two angles. 1, 2, 3, 4. So 2 ways of judging, if you have any difficulty, is, 4 distinct segments would make 2 vertical angles, or just 2 intersecting lines makes vertical angles, right? And that's even really a more reliable way, 2 intersecting lines. This is not 2 intersecting lines. This line does not go all the way through. Right? Number 24, ABC and EBR. ABC and EBR. Okay, this is not 2 intersecting lines. Here's one line, here's a second, here's a third. These are not vertical angles, all right? You can see that these 2 angles are not side by side because there's all this space in between them, but they're not vertical angles either. So these 2 angles, for sure they don't add up to 180 degrees because it would take all 3 of these to add up to 180 degrees. But these 2 angles are not guaranteed to be the same either because they're not vertical angles, right? They're made, again, with 1, 2, 3 different lines, not just 2 intersecting lines. Over here, ABC and IBM, not vertical angles. Once again, there's one line, and then there's a second and a third. Right? There is some space in between these 2 angles. They're kind of opposite from each other, but not in the way that vertical angles, true vertical angles, are opposite from each other. Right? So this was the only pair of vertical angles named in this diagram. Now, there are vertical angle pairs in these 2 diagrams. They're just not the ones that I named. Like EBR would be a vertical angle partner with CBV, right? Because there's one line and there's a second line, and those 2 lines form this angle and this angle here. So there's a vertical angle pair right there. And for that matter, this large obtuse looking angle, RBV, would be a vertical angle partner with this large obtuse looking angle, EBC. Okay? But neither one of these 2 angles here, EBA and ABC, have a vertical angle partner by themselves. And the same thing is true over here in this diagram. We have, let's see, angle CBA would be a vertical angle partner with angle TBM. Those 2 angles are the same. And then this large looking angle, CBT, would be a vertical angle partner with MBA, that large looking angle over there. Right, let's move on to lesson 3-4. Again, if you haven't printed the notes, print them. Try to do all 4 of these problems, all 4 of them. I'll give you a moment to stop the video and try them. All right, I assume you've tried these all now. So let's go through them. In this diagram, the angles with the algebraic expressions, are they vertical angles? Are they a linear pair? Are they neither? Well, hopefully you recognize that they are vertical angles because we just learned and did a whole homework assignment about them. In case you need a reminder of what linear pair means, linear pair would be angles that are side by side, like ABD and DBC, and forming a straight line. See the word line in the word linear? Linear pair means a pair of angles that are formed by a straight line and then another segment coming out of that line. Linear pairs, because they're forming a straight line side by side, are guaranteed to add up to 180 degrees, right? Whereas vertical angles are guaranteed to be congruent. So therefore, these angles are congruent. And you might have gotten these two parts of this question fairly easily, and then maybe did not know what to do here. And this is the lesson for today, is going beyond saying in your mind that these two angles must be congruent to writing an equation based on that fact. If they're congruent, these two expressions must be equal to each other. So 16x must equal 14x plus 10. Okay. And then this says, all right, once you set that equation up, solve for x. So subtract 14x from both sides, 2x equals 10, x equals 5. Is that the answer to the question? Yeah. It said solve for x, and we solve for x. So we're done. Now, if the question had said, set up an equation and find the measure of any of these angles, then we wouldn't stop here. We'd plug that 5 back in to either one of these expressions. And if we plug it into 16x, we'll get 80. And if we plug it into 14x plus 10, we'll also get 80. That's a good sign. That tells us, we did right by setting up and solving the equation. And then actually, we could also find the measures of these two angles in here without the algebraic expressions, because this angle down here would be 180 minus that 80. So that would be 100 and that would be 100. So instead of saying solve for x, I could have said set up an equation and then find the measure of angle EBC. We'd have to set up the equation, find the value of x, plug it back in, and so on. Okay. So I said this last time. Make sure that after you've solved an equation, that you have answered the question. Okay. We may not have. There may be more to do after solving the equation. Let's go to this problem over here. In this diagram above, these two angles with the algebraic expressions in them, they're not vertical angles. They are a linear pair. They are side-by-side angles. And here's that straight line that they're forming together side by side. So these two angles, they're not congruent, okay, but they do have to add up to 180 degrees. Supplementary is the word that means that, and therefore we can again set up an equation and solve for x here. But this equation looks entirely different from this one. These two angles don't equal to each other. Rather, they must add up. There's the add up. They must add up to a total of 180 degrees. Okay? And now we can solve for x. 95x equals, add 10 to both sides, 190. X is equal to 2 when you divide both sides by 95. Once again, if I asked for the measure of any of these angles now, we could plug that 2 back in. 55 times 2 is 110 degrees for that obtuse looking angle up there. 40 times 2 is 80 minus 10 is 70. 70 degrees for that acute looking angle. And 70 plus 110 adds up to 180. There's a good check of our work. Okay. The homework tonight has got a bunch of problems where you have to set up an equation that either is of this form, where two angles are equal to each other, or of this form, where two angles add up to a total of 180. If you don't set up the equation right, you are dead in the water. Okay? A lot of tonight's homework assignment is about recognizing how the equation must be set up to get you off on the right foot. That is the decision that you're going to be making over and over on the homework. Is the equation two angles equal to each other, or is it two angles adding up to 180? Okay. Number 3. All right. The angles here with the algebraic expressions, are they vertical angles? No, they're not. Okay? They're not made with just two intersecting lines. Are they a linear pair? Are they a linear pair? No, they are not. Okay? They're sort of, these two angles are sort of next to each other. Okay? And in fact, when we start talking about triangles more, which we haven't really at all this year, when we start talking about triangles, we will use the word adjacent. I've mentioned that word before. It means next to, right? If you park adjacent to somebody in the parking lot or you sit adjacent to somebody in class, you're parking or sitting next to that person. And we will talk about these angles as being adjacent angles, although we don't even use that word so much for triangles, but we will use it for quadrilaterals and pentagons and hexagons and such. But they're not a linear pair. They're not next to each other in the way that a linear pair is next to each other. And again, I remind you, a linear pair is formed with a straight line and then a segment coming out of it, and the two angles are on either side of that segment. These angles are not formed that way. They're formed by that line PQ and then a segment here and a separate segment there. That's a different, totally different picture than this one over here. Okay. If you've got a linear pair of angles, guaranteed one of them is going to be acute and one of them is going to be obtuse. Right? Or, I mean, there is the unique option of both of them being right angles. Okay. But most of the time, you're going to have one acute and one obtuse. These angles certainly both appear to be acute, don't they? They're not a linear pair. So, not a linear pair. And if they're not vertical angles, we can't guarantee they're congruent. If they're not a linear pair, we can't guarantee they're supplementary. And so they're neither of those. And there is no equation that we can set up. There's no way to find the value of x or the measure of any of these angles in this picture. Okay? So not possible. Okay. Finally, this problem here. Hey, this is a word problem, and we learned how to translate word problems into English, but there's a new phrase in this word problem that did not show up in the previous homework assignment that you have to know how to translate properly. But let's translate what we can. Where's the word is? Right there, right? So that gets translated to equals. Now, what's on the left is an awful lot. Let's look at just what's on the right. 5 to 2. 5 to 2. We don't see the expression complement. We don't see the expression supplement. We don't see angle. We just see a couple of numbers, 5 to 2. But what does that communicate to you, 5 to 2? What kind of mathematical expression is 5 to 2? Well, you might know because on the left side of the word is the word ratio. And that's what 5 to 2 is. It's a ratio, right? Now, there are 3 ways of writing ratios, I remind you, and this is one way of writing a ratio. But there are 2 other ways of writing ratios. And right now, probably the first other way that comes to your mind is using a colon, 5 to 2. So we could put that on the right-hand side of the equal sign. But wait a minute. Have you ever written a ratio like that in an equation? Have you ever seen a ratio written like that in an equation? I never have, and I wouldn't know what to do with it. But there is a third way of writing the ratio 5 to 2. What is it? Oh, again, with all the blank stares, come on. You know that you can write a ratio as a fraction. Okay, and this will be useful in the equation, far more useful than the 5:2 option. Right? So over here, when it says the ratio of, when I'm reading these word problems and I see the expression the ratio of, I stop reading and immediately I throw down a fraction bar and I say to myself, whatever comes after this phrase, the ratio of, is going to tell me what goes in the numerator and then the denominator of that fraction in that order, right? Because 5 to 2 is not the same thing as 2 to 5, which is 2 colon 5, which is 2 over 5. Completely different ratios, right? So whatever comes right after the ratio of is going to go in the numerator of the fraction or of the ratio. So what does it say? The ratio of an angle's supplement. Okay, we know how to translate that phrase from the last lesson. 180 minus x. 2, its complement. So after the word 2 comes the denominator of the fraction, its complement. 90 minus x. There you go. Okay. So now we've got a good equation. Now, I don't know that you've had to solve an equation like this year in this class yet, so let's review how to do this. I'm just going to say, look, cross multiply, which is a phrase that some teachers really don't like, but I don't know why. It's a perfectly good phrase to describe the fact that we've got to multiply this 180x times this 2. 180x minus x, times 2 equals, and then multiply this 90 minus x times this 5. 90 minus x times this 5. A lot of people call that cross multiplying, which is different from the phrase multiply straight across. Okay? Just a little side note here. You don't have to write this down, but if I'm multiplying two fractions like 2/3 and 5/7, you multiply straight across. 2 times 5 is 10, and 3 times 7 is 21. Notice there's no equal sign in this expression. This is not an equation. It's just an expression, and all we have done is simplify the expression by multiplying straight across. This is an equation, okay? And we are cross-multiplying, okay, not multiplying straight across, to get a new equation. Now we're going to distribute 360 minus 2x equals, distribute that, 450 minus 5x. Adding 5x to both sides, we'll get 360 plus 3x equals 450. Subtract 360 from both sides, we'll get 3x equals 90. Dividing both sides by 3 gets x equals 30. Okay. And then we could plug this 30 back into this expression and check and make sure that this really comes out to be 5 to 2. So 180 minus 30 is 150. 90 minus 30 is 60. Is that really equal to 5 to 2? Well, this can be reduced a lot. Divide both sides by 10, and you get 15 over 6. Not divide both sides. Divide numerator and denominator by 10, and you get 15 over 6. And then divide numerator and denominator by 3, and you'll get 5 over 2. So it checks. Everything checks. Okay? Thought there was one other thing that I wanted to say. Crossed my mind when I was talking about how to solve an equation, like, oh yeah, I remember. Here's where students get in trouble. This is one of the most common mistakes I see when students are working through a problem like this. They'll read it, ratio and angles supplement to its complement is 5 to 2. And they will not write an equation with two ratios in it. They will be in too much of a hurry, and they'll write an equation with two products in it. You remember the word product, right? A product is a word we describe, we use to describe two things being multiplied together. What is the product of 3 and 4? Well, you get the product when you multiply 3 times 4, right? So they'll be in too much of a hurry to solve this problem, and they won't want to write an equation with the fractions because, nobody likes fractions, and I forget how to solve an equation like that, so I'm just going to try to skip it, is what they're saying in their heads. And they'll write down an equation with products in it, right? Except they'll write it down incorrectly. And this is what they'll do. An angle's supplement to its complement is 5 to 2. So they'll write the supplement over here, and they know they got to write an equation. At least they've been paying attention enough to know they got to write an equation So they'll put an equation down, an equal sign down to its complement. Then they'll write the complement over there, 90 minus x. Okay? And then they read 5 to 2. And they're thinking, supplement to complement, left to right. 5 to 2, left to right. And so they'll put the times 5 over there and the times 2 over there, and look at what they've ended up with. 180 minus x times 5, whereas what we ended up with is 180 minus x times 2. See? They got the products backwards. And I see this anytime I see a student whose work begins with an equation with products rather than with ratios or fractions. They get it wrong. So do not do that. If a word problem says ratio, write a couple of ratios. These are not ratios, right? 180 minus x times 5 is not 180 minus x to 5, which is a useless thing to write in an equation anyway. I don't know what you would do with that. All right? Write out the fractions and then just drop things in the proper places in the fractions and then begin the algebra to solve. All right? Good. Oh, wait. One other thing about the homework. I hope you're still listening. Hope you didn't turn this video off here. Problem number 13 in tonight's homework. Got to give you a warning about it. Let me find it. There you go. Problem 13. Here's one of these problems. In fact, this whole page is full of word problems. And the last two word problems are ones like we did in the last homework assignment. But the first two problems involve ratios. Okay? For problem number 13, if you set it up properly, if you do the algebra properly, and you find the value of x properly, you're going to get a negative answer for the measure of the angle, which does not make any sense. Okay? Now, I still want you to do this problem, and I want you to get that negative answer. I don't want you to be confused. So I'm telling you ahead of time it's going to be negative, but I want you to do this problem because it's still a good exercise. It's good practice in setting up the equation properly and solving the equation properly. So it's still worth doing, number 13, even though the answer turns out to be a nonsensical answer. Okay? Good luck on the homework.